Get started. We've got our list of objectives. We're going to learn how to construct a frequency distribution. Part of the frequency distribution, constructing a frequency distribution, is knowing the definition of all of these things. So limits, you need your limits, your upper limit, your lower limit of your class, your midpoint, class midpoints, relative frequencies, cumulative frequencies, and boundaries. You're also going to find out about class width. So that's another thing to put on here. Class width. Okay, and then the second part will focus on how to draw the graphs. So this is dealing with the table or chart, and then these are dealing with graphs. Okay, all right. So the first thing is a frequency distribution is essentially a table, and the table has two pieces of information. So it gives you, for each class, it gives you a frequency. Notice that F is the notation for frequency. And yeah, that's here down here. So this little F throughout the entire book will stand for the frequency, okay, which is just a count. So it's the number that you have, right? So it's so let's start here. So a class, a table that shows classes or intervals of data with a count of numbers of the number of entries in each class. So when we are forming our frequency distribution, when we're constructing a frequency distribution, we're going to have essentially three things to do. So the first 1, 2, 3, 1, 2, and 3 involves setting up the classes. So steps 1 through 3, you're setting up the class, setting up the classes. Classes are essentially groups, right? So classes are intervals, that's another word for it. And then steps 4 and 5, you're setting up the frequencies. Okay. So first you're going to decide on the number of classes, usually between 5 and 20. Pretty much we're going to be, problems in the textbook, problems on the exam, it will be stated in the problem, the number of classes, right? So when it says here to decide on the number of classes, really this is more speaking practically in real life, so not so much in the classroom setting. And the reason why you don't want to have less than 5 is because if you have too few groups, right? So think of a class as a group. If you only have split your data into 2 groups, it's going to be hard to notice patterns. Or 3 or 4 groups, or 1 group. There's no point to having 1 group, right? Because you're not able to notice any trends or any patterns. And if you have a lot of groups, like over 20, so if you have over 20 classes, then it also is very difficult to find any patterns because you're going to have several classes probably that don't have any data points in them. So a good number in general is any number between 5 and 20. Okay? And it's not a hard and fast rule, it's more just guidelines. Okay. So first thing is to remember steps 1 through 3. What we're focusing on is setting up the classes. So you're going to determine the number of classes you need. Then you're going to find the class width. Now, class width, there's actually a formula for class width, and here's how you get it. In order to figure out the class width, you're going to determine the range of the data. Now, when we say the range, we mean that numerical value, which is the max minus the min. Okay. Then you're going to divide the range by the number of classes. So you're going to have your max minus min over your number of classes, right? So this is your range over your number of classes. And then you're going to round it up to the next convenient number. So it might be that a convenient number is the next integer. It might be that it's a decimal. It depends on the data set that you're working with. Okay, once you've found the class width, Now it's time to set your class limits. So you've got upper limits and lower limits. I want to look back. I'm going to show you back here in this list here, the upper limits, I'm going to highlight them in a green color. So for your upper limits, 5 is an upper limit, 10, 15, 20, 25, 30. These are all upper limits. And then I'm going to do the lower limits in this sort of grayish color. Lower limits, 1, 6, 11, 16, 21, 26. Okay, so you can see that the class width, right, is the difference between any two consecutive lower class limits. So 6 minus 1, that's 5, right? 11 minus 6, that's also 5. 16 minus 11, that's also 5. 26 minus 21, that's also 5, right? And it's also the difference between upper class limits. What's 10 minus 5? 5. 15 minus 10, 5. So your difference from here to here is going to be 5. From there, 5, 5, 5, 5, and this distance here. So notice that the class width is telling you how wide the class is, and the class width is, it has to be the same. So the width has to be the same for each class. Okay? So once you've found your class width, you're going to use that to find your class limits. And you've got upper limits and lower limits. So you start off with your minimum. So you start with your min data entry as the lower limit of the first class. And then you're going to find the rest of the lower limits. And then you find the rest of the upper limits. And so after you do 1 through 3, we are now on steps 4 to 5. We're now on steps 4 to 5, which is setting up your frequency. And so to set up your frequency, you're basically going to mark it. You're going to make a tally mark for each data entry in the row of the appropriate class, and then you're going to count the tally marks to find your total frequency. And remember, that's what this symbol F stands for. Okay, so let's do this example here, constructing a frequency distribution. So we've got a data set here. First thing, let's look, what is N? So N is equal to the total number of data entries. That's equal to, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20, 30. So we have a total of 30 different numbers here. And each of these, oh, look, we didn't even need to do that because it says here the following sample lists the prices in dollars of 30 portable GPS navigators, right? So how much does your GPS navigators cost? You can buy them online. Maybe you have them on your cell phone, right? So looking at this data, let's see if we can tell already what is the min, because we're going to need the min and we're going to need the max. So for the min, it looks like the min is 59. So that looks like the min. So let's write that down for the min. And for the max, let's see, it looks like 450 is the max. So what this is saying is that for this sample of 30 GPS, the price of 30 different GPS navigators, the cheapest one was $59, and the most expensive GPS navigator was $450. Okay. So what we're going to do is we're going to construct a frequency distribution for this data set. Okay. So let's look back at our instructions here. So what we'll need to do for the first thing is to decide on the number of classes. So how do we decide the number of classes? Well, in this case, it's given to us in the problem because it says we need to construct a frequency distribution that has 7 classes. So our number of classes should be 7. So that's step 1. So let's just put here number of classes equals 7. Okay. Now, the second step is to find the class width. So to find the class width, remember we need the range. So we need range over number of classes. That's the first thing we do. Now our range is going to be max minus min over number of classes. Now we said our max was 450 and our min was 59. So 450 minus 59 divided by 7. And what do we have? So 450 minus 59 divided by 7. That'll give us 450 divided by 59. No, 450 minus 59 should give us, let's see. Let me get my calculator. So I need 450, delete. Okay, I can't turn on my calculator. Let's see. Okay, 450 minus 59, 391, divided by 7. So if we need 391 divided by 7, okay, that is 55.85714 ... And because of our data set, because our data set is a bunch of whole numbers, we're going to round this to just 56. So we're going to round this to a whole number because our data set consists of entry points that are whole numbers. If we had a data set with like 0.1, 0.2, 0.03, 0.1, 0.7, 0.6, decimals like that, then we would probably round this number to a decimal. But for our case, it's appropriate to have as our class width 56. Okay, so this is going to be our class width. And we know our number of classes is equal to 7. So the next part we want to do is we want to find our class limits. So here's how we're finding our class limits. So 2, 3, 4, 1, 2, 3, 4, 5, 7. Okay. So you're going to have, we'll start with our lower limits, and then we'll start with our upper limits. And then we'll finish with our upper limits. So for your lower limit, the first number you want to put in is your min, which is 59. So we're going to put in here 59 for our lower limit. Now, we're going to fill in this number right here. To get this number, we're going to add 56, because 56 is our class width. So you add your class width. So 56 plus 59 is 6 plus 59, 115. Okay, and now to get the next number, I'm going to add my class limit again. So I have 115 plus 59, 174. Okay, and then I'm going to add plus 56. 174 plus 56. Wait, I think I made a mistake. So let's try this again. So I start off with your min.
15.
Start off with your min. Add 56. So 56 plus 59 is 115. 115 plus 56 is 171. Okay, 171 plus 56 is 227. Plus 56 283, plus 56, 339, plus 56, 395. Okay, so these are my lower limits. Now, to get my upper limits, pretty easy. I'm going to subtract 1. So the 115 is going to go to 114. Okay, 171 is going to go to 170, 226, 282, 338, 394. And now to get this last one here, I'm going to add 56. So 394 plus 56, 450. Okay, all right. So we now have our classes. So we have our 7 classes. And what are our 7 classes? They are 59 to 114. That's our first class. 115 to 170. 171 to 226. 227 to 282. 283 to 338. 339 to 394. 395 to 450. Those are our classes. So we've got the first half of our frequency chart done. Now the second half, of course, is going to be to come up with the tallies. So let's go ahead and prepare to do that. Okay. So we're now on the fourth one. And the fourth step is to make a tally mark. So let's paste. All right, so here's what we'll do. So we're going to do our tally marks. And in order to do the tally marks, I'm looking back at the data that I have. And the data, so see how this 90, so 90, I'm going to cross out 90 and I go here and I put a tally mark in this class since 90 is in between 59 and 114. Okay, what's my second one? Is 130. And 130 is here. The third data point is let's see, what's the third data point? Third data point is 400. So 400 goes here. 200 goes here. 350 goes here. 70 goes here. 325 goes here. 250. 275. Can you call it out to me? I'm starting at 270.
270.
270?
Yes,
Okay.
270. Then 150.
150.
130.
130.
59.
59.
200.
200.
160.
160.
450.
450.
300.
300.
130.
130. Okay, so for 130, I'm just going to mark it off like that.
220.
220.
100.
100.
200.
200.
400.
400.
200.
200.
250.
250.
95.
95.
180.
180.
170.
170.
And the last one is 150.
150. 150. Okay. So you can see why it's important for the classes to not overlap. So classes cannot overlap. And also there needs to be the classes every number should fit in a class. So there can't be big gaps. So no big gaps between classes, because then you might have a data entry that doesn't fit in a particular class. Every data entry must fit in a class. Okay, so that's basically the key point there. And our last step, so we'll say this is 4 and 5. Our last step is to tally, is to add up the tallies and actually have our frequency. So this little F symbol stands for frequency. So this is going to be a 5. This is going to be 7. This is going to be a 6. This is going to be 4. The frequency of this class is 2. The frequency of this class is 1. The frequency of this class is 3. Okay. So notice that the sum of the frequencies is equal to n. So if you add up all these numbers, right, so what does this sigma mean? This sigma, so sigma means add up, right, so if you add up all the f's, it should be equal to n. What happens if we add them up? We get 5 plus 7 plus 6 plus 4 plus 2 plus 1 plus 3. 28. Uh-oh, we made a mistake. We got to go back and fix it, right? So wait, 5 plus 7 is 12, plus 6 is 18, plus 4, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Made a mistake, got to do it again. Okay. All right, this is real life, people. All right, so we got to go back and do our tallies. Again, because we left off some numbers, and if we don't have all of our data, then our frequency distribution is won't be accurate. Okay, so let's call out the numbers again.
90.
90, got it.
130.
130, got it.
400.
400.
200.
200.
350.
350.
70.
70.
325.
325.
250.
250.
150.
150.
250.
250. Let me see. 250.
275.
275.
270.
270.
150.
150.
130.
130.
59.
59.
200.
200.
160.
160.
450.
450.
300.
300.
130.
130.
220.
220.
100.
100.
200.
200.
400.
400.
200.
Another 200. Got it.
250.
250. Got it.
95.
95. Got it.
180.
180.
Mm-hmm.
Got it.
170.
170. Got it.
150.
150. Got it. All right, so let's do our F's, our frequencies. So that'll be 5, 8, 6, 5, 2, 1, 3. And what is the sum of F? 30. All right, so where did we, that was wrong. That should have been an 8. Our second class was off, and then 6, and our fourth class was off. That should have been a 5. Okay, and now we'll get 30. Good job. All right. Okay, so you can kind of get an idea of why I like to emphasize using technology, because it's a lot easier to go back and make and correct your mistakes if you find your errors, if you have errors. So you'll notice in this course I will not be doing too much stuff by just pencil and paper. The reason why I wanted to do this was to give us a good solid foundation for constructing these frequency distributions. But in general, if we can do it on a computer easily or a calculator, we will do that. All right. So we've got our frequency distribution, and I believe that's it. So the next thing here is determining the midpoint. So determining the midpoint of a class. And what I'm going to do is I'm going to determine the midpoint, I'm going to actually, let's see here, paste. Remember, these were our classes. These were the classes. So we could write down, let me see, it'd be lovely if I could make this smaller. But I don't think I can. I think it's just a raw cut and paste. We can go ahead and find the formula for the midpoint. So if we write the midpoint of the class, here's how we do it. You take your upper, so we've got this formula. Make sure you know this formula. The midpoint of a class is the lower plus the upper divided by 2. Okay? That's probably not that appealing visibly. So let me just say, here's the formula you need. Is that the midpoint is the lower limit plus the upper limit divided by 2. So for instance here, we would take 59 plus 114 and divide by 2. And you see that's what they've done here. They got 86.5. So you can find the midpoints of each class, right? So 115 plus 170 divided by 2, that gives you 142.5. You can do that all the way down. Notice that the difference between the class widths is equal to, the distance between the midpoints is equal to the class widths. So the distance, the distance here, the difference, this difference is the class width. This difference here is the class width. And this difference here between the midpoints, class width. So the difference between the lower limits of any 2 consecutive classes is the class width. The distance between the upper limits of any 2 consecutive classes is the class width. And the distance between the midpoint of any 2 consecutive classes is the class width. Okay? Now let's see here. So we can determine the relative frequency. We've got another formula. Relative frequency of a class is going to be the class frequency divided by the sample size. Okay, so you can look here, and for each class, you can calculate the relative frequency. So remember how we had our frequency was 5? Well, our relative frequency is going to be 5 over 30. For here, the frequency is 8. Relative frequency is going to be 8 over 30. Because remember, for us, so for this data set, n is equal to 30. Okay, so each time you're dividing by 30. And the last thing is the cumulative frequency. So cumulative, remember how you can have a cumulative GPA? And a cumulative GPA doesn't take into account just your GPA, your scores from last semester, but it takes into account your grades for all of the grades you've ever had up until that point. It's the same thing with the cumulative frequency. So to get the cumulative frequency, you are literally just going to add all of the frequencies up until that point. So the cumulative frequency for this class right here, for the second class, is going to be 5 plus 8, which gives you 13. Okay, and then to get the cumulative frequency for the next class, you take 5 plus 8 plus 6, which is going to be 19. Okay, so the cumulative frequency of a class is the sum of the frequency for that class and all previous classes. And we can form here, now that you've got your midpoint, so once you've got your midpoint, your relative frequency, and your cumulative frequency, this chart is now called your expanded.
1530.
Thank you. Your expanded frequency distribution. Now, just in general, if you just have this beginning part right here, that is just your frequency distribution. But once you add all of this information, it is your expanded frequency distribution. And please note that, as we said before, the sum of your frequencies is N. So let me highlight this. So the sum of your frequencies is equal to N. So this is always. The sum of your frequencies is equal to N. The sum of your relative frequencies is equal to 1. So the sum of your relative frequencies is equal to 1. And the last cumulative frequency, the cumulative frequency of your last class is always equal to N. Okay? So those are some patterns to notice. So for our next part, we're going to talk about graphs of frequency distributions. Here's where we'll actually use the midpoint more. So we're going to have, notice that for a frequency histogram, anytime you have a histogram, your horizontal scale has to be quantitative. Okay? So we'll have a quantitative values on our horizontal scale, and always frequency is on your Y scale. Okay? And then lastly here, consecutive bars must touch. And a frequency histogram is a bar graph that represents the frequency distribution. So let's do an example. And in order to figure out how to do the, wait, I'm missing a slide. I am missing a slide. In order to figure out, oh no, it's coming later on. Okay. So in order to do a frequency histogram, you've got two basic ways you can do a frequency histogram. Let's just fast forward to this example. Right, so suppose we had an example where we want to construct a frequency histogram. Now we already have our class and we already calculate our, suppose you calculate your class boundaries. So we'll talk about class boundaries in a little bit. You can form your histogram using midpoints or using class boundaries. So we already know about midpoints. So let's look at how to do the frequency histogram using midpoints first. The midpoint of each class is the center of your histogram bar. Okay, so you see your center of your histogram bar here is a midpoint. And how high the bar is depends on the frequency of that class. So you get an idea here. So the second class had a midpoint of 142.5 and it's got a height of 8. So the midpoint was 142.5 and it has a height of 8. Notice that, remember how we said that the distance, we said that between from here to here is 56 and between here and here is 56. The class width is the distance. Remember how we said that? That means that the size of our rectangles are going to all have the same width. So the class width corresponds to the width of the rectangle. So let's write that down. Class width corresponds to the width of the rectangle in the histogram. So that's why in the histograms, okay? And so that's why it's important that your class width be constant. Okay, we're going to need that. We'll put that. Let's put that here. We'll put that note here as well. Okay, so now let's talk about the second way to construct a frequency histogram, and this is using class boundaries. Now, class boundaries are pretty simple to calculate. Pretty much what you're going to do for your class boundary is you're going to look at, now remember these are lower limits, right? So if you have your lower limits, lower limit, subtract 0.5, and that's how you get your lower boundary. So 171 minus 0.5 gives you 170.5. Right, so you subtract 0.5 to get your lower boundaries, and then for your upper limits, you add 0.5 to get your upper boundaries. So see how we're adding 0.5 to get our upper boundary here? 170 is going to go to 170.5. Right, 226 is going to go to 226.5. So you got your lower limit, your upper limits, your lower boundaries and your upper boundaries, and your midpoints. Okay? And now, if you're using class boundaries, what you're going to do is instead of marking the midpoint, you're going to use your lower and your upper boundary. So 58.5 and 114.5, those are your upper and lower boundaries for your first class, right? 58.5 and 115.5. So those are the limits for, you use the boundaries as the limits for your rectangles, okay? And then according to this, you can see that more than half of the GPS navigators are priced below $226.50. So let's look at that. What would that mean? How do we know that? So if we look here, now, which GPS navigators are priced below $226.50? Anything in here, right? So these are priced below $226.50, and these are priced above, right? So if we wanted to see how many of the GPS navigators are priced below, so let's add it up. So we'd have 6 plus 8 plus 5, 6 plus 8 plus 5, which is 19. And that is definitely more than half, because all of the 30 is equal to the total number of GPS navigators, right? So 30 is equal to total. So definitely 19 is more than half of the navigators. And also, if you look at the area of the rectangles, these rectangles, there's more area here than if you compare it to if you add up this area here, right? So if we add up these rectangles, the green rectangles don't have nearly as much area as the purple rectangles. All right. So the next thing we want to learn is how to graph a frequency polygon. Okay, and it's a line graph that emphasizes the continuous change in frequencies. So our goal here is to construct a frequency polygon for the GPS navigator's frequency distribution. Now, in order to construct our frequency polygon, we're going to need this information. So you need to know your class. From your class, you're going to get your midpoint and then your frequency. So in order to do this, we start off. I'm going to draw my horizontal axis and my vertical axis, and I can draw a little broken line here. Okay. All right. So I start off by plotting my midpoints. So how many midpoints am I going to have? 1, 2, 3, 4, 5, 6, 7. Because again, we have 7 classes. Okay, so I've got 7 midpoints. So I start off by doing my midpoints. 1, 2, 3, 4, 5, 6, 7. 86.5, 114. So let's go ahead and put those in. So this is going to be 86.5, 114, or sorry, 142.5, 198.5, 254.5, 310.5, 366.5, 422.5. Now I'm going to add one more to the left and the right endpoints. To get this last value here, what I'm going to do is I'm going to add 56. So I'm going to add 56 to get this last endpoint. And what is 422.5 plus 56? So that should be 478.5. Okay. And now if I subtract 56, what is 86.5 minus 56? So that should be 30.5. Okay. Now I'm ready to put in my axis here, my vertical axis. So let's see here. So this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm doing that because, look, my highest frequency is 8 and my lowest frequency is 1. So if I go from 0 to 10, I should be good. So this is 10, 1, 2, 3, 4, 5, 5. Now, these small endpoints, I'm going to make that a 0. The left and the right endpoints are always going to be 0. Now just plug in my frequencies. So the midpoint 86.5 corresponds to a frequency of 5. So I'm going to plot that point. And then the next class has a frequency of 8. So I go up to 6, 7, 8. So this one's going to go up to 8. And then down to 6. And then down to 5 again. Back down to 5. And then down to 2. And then down to 1. And then up to 3. And then back down to 0. And finally, I'm going to connect with just straight lines. And so this is our polygon. All right. Okay. So the two essential graphs that you need to be able to do are a histogram and a polygon. Okay. Now, once you have a histogram, you can create, once you know how to do a histogram, from there it's easy to create a relative frequency histogram. It's going to be pretty much the same thing. You're going to have down here your data values, and up here, instead of doing your frequency, you're going to graph your relative frequency. So it has the same shape and the same horizontal scale, right? So same horizontal scale. Down here, you're going to have your different classes as the corresponding frequency histogram. But the only change is that for your vertical scale, you're going to measure relative frequencies as opposed to measuring just frequencies, okay? So we've got a picture here. You can look at the data. You're going to be graphing your class. So you still have your class boundaries, but now instead of graphing your frequency, you're going to graph your relative frequency. And the benefit of using relative frequency instead of frequency is that now we have a sense of proportions. So as we see here from the graph, you can see that 20% of GPS navigators are priced between $170.50 and $226.50. So notice here, 20%, that's the same thing as 0.2, right? And so this rectangle here, what this rectangle means is this represents the number, the relative frequency, so it represents the percentage of all of the GPS navigators that are priced in between 170.5 and 226.5, right? And so we can see about 26 or 27% are in between $114 and $170, and you can get a picture of the percentages very quickly just by
It's
using
1545.
just by using the relative frequency histogram. Okay. Similarly, you can do a cumulative frequency graph, polygon, okay, or ogive. Okay, so a line graph that displays the cumulative frequency of each class at its upper class boundary. Okay, So that's the key thing here is for here, your vertical axis, your vertical scale is going to be keeping track of the cumulative frequency. For the horizontal scale, you're actually going to use the upper class boundaries, okay? So we're not going to use the midpoint. You're going to use the upper class boundaries. So I'll let you read that, but you can look and see. So we're going to use our upper class boundaries as our horizontal scale. But now we're going to need some place to start off with. So you also throw in that lower boundary of your first class. So see, that lower boundary of your first class, you set it equal to 0. And then for each of your upper boundaries, upper class boundaries, you go ahead and you plot them. This, you should always end up, right? Your last mark here should be your last upper class boundary, and this should be at n. So whatever your n is, that should be the high point of your graph. And now here, notice from the ogive, you can see that about 25 GPS navigators cost $300 or less. So you can say how many GPS navigators cost less than $300. So let me go down here and look, where's $300? Maybe here's 300. So maybe here's 300. So maybe that's 300. And so I'm going to follow that up. I'm going to say, okay, 25. So all of these, when I add up how many are less than 114, there are 5. How many are less than $170.05? How many are less than that? 13. Why? Because, let's look back at our cumulative frequency. Remember how we got our cumulative frequency was to add it, right? So 5 plus 8 is 13, and then we add 6 and we get 19. So there are 13 that are less than 170.5 because there are 8 that are in this class and 5 that are in this class, right? So you get a total of 13 that are less than or equal to 170. Okay? So you can see how there are benefits, there are pros and cons to each graph. Each graph gives certain information and presents it in a way that is very clear. So from here, it's not very clear how to see percentages, right? But it is clear to give information about overall less than or equal to $300. That's easy to see, right? So just make sure that you are familiar with how to construct your frequency distributions with your midpoints, your lower and upper limits, your lower and upper boundaries, okay? And then also how to construct an extended distribution, which means you're including not just your class and your frequency, but your midpoint, your relative frequency, and your cumulative frequency. And then, so all of this is about tables, this first part. And then part 2 is make sure that you are familiar and comfortable with your histograms and your polygons. So you've got histograms, which are the bar graphs, and you've got polygons, which are the line, right? So those are the line things. So like there that ends at 0, right? That starts and stops at 0, or something that goes and is always increasing. I don't know why I'm drawing it like that. Right, so this could be a cumulative. This could be an ogive because it's always increasing. And this could be a frequency polygon. Okay, and you've got your histograms, which are your bars. Okay.
We're going to start talking about stem and leaf graphs first. And when you have a stem and leaf plot, each number in your data set is going to be separated into a stem and a leaf. The leaf is going to be the last digit in your number, and the stem is going to be everything else to the left of that last digit. So you want to make sure that when you're finished with your graph, that your number of leaves is the same as the number of data values in your data set, because each of those leaves represents a data value in your data set. So that's a way you can make sure that you didn't miss any values in your graph. Okay, so first of all, let me list the steps here. Steps. Okay, step 1 is you want to sort the data. Because you want to be able to find the smallest and the largest number very quickly, because that's going to help us identify what the stems are. Now, in this data set for this example, it's already sorted for us. We always want to go for this. It's easier to go. I shouldn't say we have to go in increasing order, but it's easier. You want to go in increasing order, so you want to go from smallest to largest. And if you notice, our data set already does that. Now, typically with stem and leaf graphs, the data set's fairly small and it would be easy to do that by hand. If you have a larger set of data though, and you don't want to have to worry about trying to sort the data by hand, there is a way to sort it very quickly on your calculator. Okay, step 2 is you want to identify your stems. Okay, so the stems are going to be the numbers to the left, and your leaf is going to be that last digit on the right. So by identifying the smallest and the largest numbers, we can see what our stems are going to be. So when I look at our data set here in the example, our smallest number is 1.1, and our largest number is 12.3. Since the last digit is going to be our leaves, so in this case, when I look at the smallest number, our leaf for 1.1 is going to be 1, because that's our digit to the right. And for our largest number, our leaf is going to be 3, because that's our digit to the right. And now, so I can identify what my stems are going to be. My stems are going to be the numbers 1 through 12. So in this case, I'm going to have stems. Let me make a note of this. Stems are the numbers 1 through 12 for this example. Okay, now once you identify the stems, you're going to actually, so let me put this as step 3. You're going to draw a vertical line and list your stems. Now, it's very important that even if you don't have leaves for that stem, you still need to put that stem in there. And when you list it, you'll just have a blank line there if you have no leaves. Okay, so there's my vertical line, and my stems are going to be the numbers 1 through 12. All right, now the next step, step 4, is to fill in your leaves. Okay, so now this is another reason why it's very handy to have your data values in order, because now I can identify everything that's going to fall under the 1 categories. When I look at 1.1 and 1.5, my leaves for 1 is going to be 1 and 5, because those are my last digits. So I'm going to put 1 and 5. For my stem of 2, I'm going to have 3, 5, and 7. Those are my digits that go with my stems of 2, because these are my digits on the right. Okay, now I'm going to look at 3. So for 3, my leaves are going to be 2, 3, 3, 5, and 8. Now, even though I have a leaf that is listed here twice that's the same, I still need to list that twice in my leaves. So I want to make sure that if there are multiple digits that are the same, I still have that same number of digits in my leaves. So make sure you count those multiples. Another thing that is important here is that you line up your leaves so that they're in columns. So even though we don't write it here, imagine that you have a dotted line separating these so that all your numbers line up. It's important to do that because later when we talk about the shape of the data, if you don't have those lined up, you're not going to get an accurate shape. Okay, so imagine that you have those invisible lines. For STEM 4, I'm using these numbers. So I have 0, 2, 5, 5, 7, and 8. For 5, I have 5 and 6. And then for 6, I have the digits for leaves 5 and 7. Now, I don't have any leaves for numbers 7 through 11, so I just leave those blank. And it's important that you do that because if you have, for example, when we have this leaf that goes with 12, you can identify outliers. If I put the 12 right underneath the 6 and I didn't show that gap, it would be hard to see that this was an outlier. So this is kind of off to the side away from the rest of the data. So that's very, very important to make sure that even if you don't have leaves, you still show those stems. The last step, I'll put number 5, is to make your key. Now the purpose of the key is to make sure whoever's reading the graph will understand what these values represent. So let's see, I'll write it down over here. So you can pick any number you want, it doesn't matter. I'm going to pick this right here. So I'm going to pick the data value of 3.2. Now the whole purpose of the key is to make sure that the reader understands what that 3 and that 2 means, because if someone's looking at it, they can interpret that as a 32, for example, even though this really represents 3.2. So in here, I'm going to write 3/2 is equal to 3.2, and then you always want to make sure that you put in your units. The 3.2, that represents, if you look at the problem, that represents kilometers. So I'm going to put in there kilometers. If you forget what units you're dealing with, always go back and look at your question. Now, there are times that you're doing this just to practice, and there won't be any units in the context of a problem. And in that case, you can just write 3/2 is equal to 3.2. But if this is in the context of some problem, you want to make sure that you label what that represents, what the units are. Now, I could have picked, and it honestly doesn't matter, I could have picked 6 and 5 here, and I could have wrote 6-5 is equal to 6.5, and then kilometers. It doesn't matter what number you use. The point is you're just trying to make sure that the reader understands what those numbers represent. Okay, now let's talk about what's called a side-by-side stem and leaf plot. And this is really useful because it allows you to compare two data sets together in one stem plot. And I put on your notes here, you'll see, I think in our book it's called a side-by-side stem plot, but sometimes you might see it listed as a back-to-back, but it's the same thing. Now, going through our steps for a stem plot, it's all going to be the same, except you're going to have two stem plots back to back using one column for the stems. Let's go ahead and put this data in order using our calculators. Okay, let me show you how to sort data in increasing order on your calculator. So the first thing you want to do is you want to enter your data values, and you do that by hitting this stat button right here that's a little bit to the left of your arrows. I'm going to go ahead and hit the stat button. Then what you want to do is you want to access your lists by coming under here where it says edit on number 1. That's where we're going to enter and edit our data values. So then I'm going to hit enter. If you have data already in your list, you can clear the whole list by hitting clear enter. But you have to make sure first that you are highlighted on the list that you want to clear out. So if I want to clear out the entire list 1, I highlight L1 and then I hit clear. Now, if I want to just delete one specific entry, let me just put some data values in there. Let's say I just want to delete the 6 in this case. I would come up to the 6 and make sure that it's highlighted, and then I would use the delete button rather than the clear button. So I would hit delete, and then it would go away. So that's a quick rundown on how you clear or delete entries. Okay, so to enter the data values, we have to do this in 2 separate lists because we have 2 data sets. So I'm going to use list 1 for the 3 o'clock class data, and then I'm going to use list 2 for the 8 o'clock data. So to enter your values, you're just going to hit your number and then enter. Okay, and then you're just going to go ahead and enter all those data values just from the 3 o'clock class. So pause this video and just do that. Once you finish your list 1 and you put in all your data values for the 3 o'clock class, then arrow over to the list 2 and go ahead and enter your data values as well. Okay, once you have all your data entered in, one thing you can check to make sure you didn't miss any values is notice when I'm highlighted on this 22 here. If you look at the bottom, we have some notation here. And so what this is telling me is this first number, L2, means my cursor is in list 2, and then 28 means the 28th entry down. So if you want to make sure that you didn't miss any numbers, what you can do is highlight the last number. So the last number that I have on here is 28. So it says I'm sitting in list 2 at entry 30. And if you go back and check, you have 30 data values. So I know I didn't miss any. Now that doesn't mean I didn't make a typo somewhere in between, but at least we know for sure that I didn't miss any. And then you can do the same thing with the first list. If I highlight my last entry, my cursor is sitting in list 1 at entry number 26. And if I count my data values for the first data set, which is for the 3 o'clock class, I can see that I have 26 data values. So I know I didn't miss any. Now, we still want to make sure that we didn't do any typos. So it's probably a good idea for you to always go back and double check, but that will help you determine if you missed anything. Okay, once you get your data values listed in there, we want to sort, for this case, we want to sort the data in increasing order. So what I'm going to do is I'm going to hit the stat button again. Under the edit menu, you'll see an option number 2 that says sort A, and then you'll see an option number 3 that says sort D. These are both sorting functions. The difference between the two is sort A means sort for ascending. So that means from lowest to highest, which is what we want. The sort D is descending, so that would be from highest to lowest. So it's just the order in which you want to sort. For us, we want to sort ascend to go in increasing order. So I'm going to hit enter on number 2. And then it will bring us back to our home screen. Now I want to tell it to sort list 1. So I'm going to hit the second button, and then I'm going to hit the number 1 button, because if you see above the 1 button, you'll see list 1. So I want to do the second option first before I hit 1 so that I access that L1. And then I'm going to close parentheses and I'm going to hit enter, and it will say done. Now I'm going to do the same thing for list 2. I'm going to sort list 2. So now I'm going to hit second number 2 so that when I have my sort A and I'm telling it which list to sort, I'm telling it to list the second list now. So that's the L2 above your 2 button. Then I'm going to close parentheses and I'm going to hit enter. And that says done as well. So the calculator just told me that it finished sorting. So now if I hit the stat button and I go back to my edit under option 1, I can go back and see that now my data for list 1 and list 2 is sorted in order from smallest to largest. Oh, and it looks like I have a typo here because we don't have any 2s in this data list. So that is a good indication that I need to go back and check my data. Now that we have the data sorted and you make sure that there are no typos or anything like that in your list, the next step is to identify your stems. Now, because we have 2 data sets, we want to check the low and the high values for both data sets because the stem in this case, all of those stems need to work for both data sets. So when I look at the lowest value for the 3 p.m. class, it looks like the smallest value is going to be 35. And it looks like the largest value for the 3 o'clock class is going to be 85. Now let's look at the 8 p.m. class. When I look at the 8 p.m. class, it looks like the lowest value is 18, and the highest value for the 8 o'clock class looks like it's 56. Because we want the stem to work for both of these data sets, my lowest value for both of the data sets is 18, and my highest value for both data sets is 85. So I want to make sure that my stems that will work for the numbers 18 to 85. So that means when I write my stems, I'm going to write it so that I have the numbers 1 through 8. 1, because of this 18, that's going to make it so that it works with the lowest number between both data sets. And 8, because that's the maximum between both data sets. And we want all the numbers in between. So I'm going to make my stems here. So I have 1, 2, 3, 4, 5, 6, 7, 8. Now this is going to be in the center because it's going to work for both data sets. So now I need to label which side is which so that it's not confusing. I'm going to put the 3 o'clock class on the left and I'm going to put the 8 o'clock class on the right. It's important to label everything when you're graphing so there's no confusion. So when we're plotting the data for the 3 o'clock class, it's going to be a little counterintuitive because we want to come from the stem out. Typically when we order numbers, we go left to right. But in this case, because it's coming out to the left, we're going to go order it from right to left. So it's a little counterintuitive, but just keep that in mind. So when you look at the sorted data on your calculator, the first number is 35. So I'm going to list a 5 under 3. Then the next number, if you entered it in right, should be 38. So then I have an 8 coming out this way. So notice what I mean by counterintuitive. Normally we would look at the 5 as being on the left and the 8 as being on the right because we write it in increasing order from left to right. But because the leaves are coming out this way on the left side, you want to make sure that your smaller numbers are closest to the stem. Now I'm going to go ahead and finish writing all my leaves. I would like you guys to try pausing the video and to write your leaves for the 3 o'clock class and then unpause to make sure, and you can check your answer with mine to make sure you got it right. So here are your leaves for the 3 o'clock class. Double check and make sure you got those right. And then we're going to move on to the 8 o'clock class. I'm going to go ahead and do the first couple for you to make sure we've got it right. Now that we're on the right side of the stem and leaf plot, we can actually go and use our intuitive method of going left to right when we're writing our numbers in order. So when you look at your calculator and you look at your sorted list for the 8 o'clock class, you have a bunch of 18s. You should have 5 of them if you entered your data correctly. So that means I'm going to have 5 18s, so I'm going to have 5 8 leaves. And then the next number would be 19, and it looks like you have 5 of those as well. So I'm going to have 5 9s too. So go ahead and pause the video and start making your stem and leaf plot for the 8 o'clock class, and then unpause it and check to make sure it matches with mine. Okay, now this should be your finished product for your back-to-back stem and leaf plot. So now it's an easy way to compare data side to side. And then the last step, we want to make our key so that anybody that's reading this knows exactly what these numbers represent. So I'm going to use these numbers here. So when you're doing a back-to-back or side-by-side stem plot, you want to make sure that you're including both sides when you make your key. So I want to put down here key, and I'm going to write. Now you can use any number you want on here to identify it. However, I'm going to pick this. So I'm going to do 5/3/1, and I'm going to put that means 35 and 31. And then this is years old. Make sure you include your units in your key. So that is how you make a side-by-side stem plot. You're basically just doing 2 back-to-back where it's sharing the stems. The only thing you have to be careful of is to make sure that when you're doing the left side of the stem plot, that you remember that the numbers closest to the stem should be the lower numbers as you work out.
How about circle graphs? So circle graphs are a visual way to represent data from relative frequency charts. To make a circle graph, you basically add a column onto that relative frequency table that includes the degrees in the circle. Since a circle has 360 degrees, you multiply the percentage by the number of degrees in a circle by 360. So for example, if we go back to the Harry Potter example, the number 3, right, the number of people that chose the Prisoner of Azkaban, that would be 20% of the circle. So it would be the 360 times 20%, right? Or 360 divided by 5, which should be a 72. So I would use 72 degrees. So that's basically what's going to happen. So we're gonna not use the Harry Potter example, but we're gonna go ahead and walk through making an example of this, right? So basically what's going to happen here is I'm going to add a relative frequency section, right? And so that relative frequency is going to be whatever number chose, for instance, in this case, cooking or electrical or unknown, etc., over the total of the 1,200 people that asked, right? That's the relative frequency. And then from that relative frequency, I'm going to multiply that by 360 to find the number of degrees, right? So this would be 1,200 out of 1,200. And then I'm going to go ahead and multiply to get the degrees. And then we're going to try really hard to draw this with a protractor, which is going to be super duper fun. And I am very much being sarcastic when I say that, but we're just going to walk through it. I'm never, ever, ever going to make you draw a circle graph by hand, but I want to just walk you through how they work and what they're made of. So the total degrees in a circle is 360, right? So basically what I'm going to do, I have a 312 over the 1,200 as the relative frequency. I have a 216 over the 1,200. I have a 60 over the 1,200, another 60 over 1,200, a 120 over 1,200. That one's at least nice, and a 168 over 1,200. So basically, to get the number of degrees, I'm going to take this number times the 360 degrees to get the number of degrees. So let's go ahead and walk through this. I'm going to be a little bit lazy here, so I'm tired of typing this in my calculator. So here's what I'm going to do. I'm gonna say that it's some number over 1200 times 360. So here's what I'm gonna type in my calculator. I'm gonna type 360 over 1200 times x, and then I'm just gonna change what the x is a bunch, because I'm lazy and that's easier. So here's what I'm gonna do. I'm gonna type in that I want 360, and if you want, you don't have to switch the order. You can literally make this x the number we don't know. So if that makes you feel uncomfortable doing what I did, you can type x over 1200, meaning x is this number, right? I'm going to call this x just to make my life easier. This is one of those like math life hacks, times 360. Okay, and then what I'm going to do is I'm going to go to table set, and I'm just going to jump to the number I want. I want 264. And I can go by ones. It doesn't really matter. I'm not going to be changing my table in particular. But I'm going to go by ones. Sorry, I went down too many. Silly calculator is all glitchy and frozen. Okay, so I'm going to go by ones. Here you go, calculator. That's it. Okay, so if I go to table, it's going to give me the 264, and that's a 79.2. So I say, cool, 79. And I could check for more details. Like I could scroll over. If I go over, it'll give me more details if there are more. In this case, there aren't, so it's just 79.2. Then I'm going to go back to table set, and I'm picking the 312. Now there's other options, but really this is a pretty quick alternative to not feeling like plugging in a bunch of stuff. So I get a 93.6 degrees, right? So this is how many degrees I'm going to use. I'm going to go back to table set. I'm going to pick a 216. Go back to table. It's going to be the top number. Cool, that's a 64.8 degrees, right? 60 over the, so I'm going to go ahead and the 60 occurs twice, which is nice, so I can bust that out. You could also probably figure this one out logically because it's an easy number relative to the 1200, right? So this is 18 degrees. This is also 18 degrees. This is definitely a 1/10. 120 over the 1200 is definitely 1/10. So this is going to be 36 degrees. Sorry, didn't mean 360, I meant 36. There we go. And that's fine. If you need to type it in, you certainly could. And then the last one's the 168, so I'm going to go back to my table set and do 168. I don't care what method you use. You're not doing this by hand. There's no way you're spending the time to find these numbers by hand. So given that you're not finding them by hand, you might as well just find a good, fast life hack way to do it in a calculator. So now we're going to draw this. We're not going to spend a ton of time on it. It already feels like we've spent a lot of time. Here's how you do it. You draw a circle, you draw one radius, preferably horizontal. Sorry, didn't mean to make that giant. Okay. So then you're going to line this center thing up on that line, right? And what you're going to do, and we'll see, I think it actually might let me do it. I'm experimenting with this, honestly, for a bit the first time, like kind of the first time. So I think if I do this, hang on. I think if I grab this, I can take it up to, I want to go to, so it doesn't matter how you do it. I'm going to go up to the 79.2, right? You can do it this way, honestly, if you were doing it on paper. So it's a little hard to see, but so there's 50, 60, 70. 79.2 is darn close to 80. It's going to be about there, right? And then I think it actually sets it for me if I do this, maybe. Close. I don't want it to, so that was close to 79.2. If I do this, it actually gives me the angle. Now, that's fine, but what's annoying about it is that I want it to be centered, right? I want it to be centered a little bit better. So that would be the first section of my circle graph. In this case, you can actually use this protractor to do that. If you were doing it by hand, that's not what you would do, right? If you were doing this by hand, oh, not what I meant. Oh, well, we'll figure it out. So if you were doing this by hand, nobody wants that. There it is. Okay. So what you're going to do is you line up on the next spot, right? The spot that you just got, you line that up. And then, so I did the 79.2, right? I did this guy. Now I want a 96.3 or 93.6, which is basically a 94. So I'm going to go here. I'm going to try and drag this guy, if it'll let me. It's being quite stubborn. Not what I want. That's what we want. Come on. Okay, let's shrink it a little to see if it'll let me do it. Okay. So it's being incredibly stubborn. I apologize, guys. So basically what we're going to do is using a regular protractor, in fact, that's how we're going to do it because I'm kind of over this thing, to be honest. Using a regular protractor, what I would do is, and we'll use black for this, I would measure from this line and I would go to where 94 is. So here's 90. This is probably 94, right? So that's right about there is where I would draw my line. So then I'm going to move this guy for a sec. my line would be somewhere around here. And yeah, that's not perfect, but you get the gist. So we have the first section. This is my 94 degrees, right? That's the next section. From that 94, right, so now I'm going to take this thing. Again, we want to make sure that we center things on this line, and that's not perfect, but you get the gist. So from the 94, now I want a 64, right? So again, if I don't have the fancy protractor, like this thing is annoying and I can't get it to move anyway. So if I don't have that thing, I'm going to start here and I'm going to go, so there's 10, 20, 30, 40, 50, 60. I want 64-ish, so that's somewhere around here. Perfect. It's not exactly right, but it's fine. So that's my next one, right? That's my 64. Then I need a couple 18s. So what I'm going to do is I'm going to rotate this thing again. Again, it would be much easier if this were a regular protractor in the real world, but it is what it is. So I rotate it again, and now I want to rotate so it lines up on that line and so that that point is still at the center. I need two 18s. So honestly, I'm going to bust out both 18s real fast. I'm going to say, hey, there's an 18, right, around there. And then here's 32, there's 36. So that's probably about the other 18. So I'm just going to bust both of those out right now. So there's my first 18. Oh, wait, sorry, it's doing an annoying thing. So there's my first 18. It's not perfect. There's my other 18, right? So both 18s are done. Now I need a 36. And again, I get that this is tedious if you've completely checked out and you were like, cool, Hogan, so I'm never doing this by hand. I can't blame you. That's fine. So I need a 36. So again, I line this up with the last line. I count out to, there's my 30. So there's about 36. It doesn't have to be perfect, right? And then I move this guy out of the way. And so you'll notice the 36 is about twice as big as the 18s because it should be, right? And then the last one I should get is about a 50.4. And if I did my job right, then this is close enough to a 50.4. Nobody's going to judge if it's not perfect. So sure enough, we line up here. Yep, that's about right. It's a little bit high, right? It's a little bit high, so it means that one of my angles is slightly off, but I'll take it. And then once you're done, you're usually going to end up color coding, right? You'll say something like, hey, cooking, this is cooking, right? And you'll color code it on your pretty graph. And then you'll say something like, hey, here's neon green for electrical, right? And then this will be your neon green, right? And that's how you'd make your circle graph. I'm just way too lazy to do this. So you might say something like, unknown is purple. That's really vague and makes me nervous that many house fires are caused by unknown things. And then maybe you'll say something like, children can be this little section right here. That's a surprisingly small number given how dangerous children can be. And I don't know, maybe we'll use seafoam green for one, right? So open flames, very enthusiastic, seafoam green, right? And then that's probably like a periwinkle. Let's see. All right. So we'll use smoking can be this color, right? And that's kind of the idea, right? So you're going to color code your terrible much nicer than my circle graph. So I am going to walk you through this tedious process one more time, right? So that would be the last one, right? And I'd color code it on my circle graph. And then you'd have a key that labels them, but I'm way too lazy for that after we worked this hard to get here. So I'm going to do this one more time on a practice problem. The good news about this one is it's only 4 items, which is helpful, right? I do need to, in this case, find out what the total number of items are because I wasn't given that as a choice, right? So I am going to have to find the total. It's going to be 891 plus 627 plus 235 plus 122. It'd be nice if they gave me a nice number. It's not the best number, but it's not awful. So my total number is the 1875, right? So basically, to find my number of degrees, right? So if we wanted the relative frequency, it's going to be this number, right? So the 891 divided by the 1875, right? And then the 627 divided by the 1875, and the 235 divided by the 1875, and the 122 divided by the 1875. And then to find my degrees, right, which I'll do here because I'm going to move this guy up a little bit, right? If we want to find our degrees, again, I will never make you do this by hand. I just want you to get the logic of how it works. You can totally skip the rest of this video if you are over it. So I'm going to go ahead and find whatever this number is times, so essentially I'm just going to do that same thing I did before where I cheat and I say cool. So I'm going to say that x over 875 times 360 is my number of degrees, right? And so I'm going to go ahead and do that in my calculator and just plug in those values, right? So I'm going to go ahead and change this to an x, and instead of being a 1200, we're going to change it to, if the calculator would scroll fast enough that it's not making my head explode, we will change it to an 8, 7, and a 5. Oh, it did not scroll fast enough to not make my head explode, and this is where we're at now. Cool, we're just going to clear the whole thing because it's frustrating. X divided by 1875 times 360. Cool. Then we're going to go to table set. I'm going to go ahead and type in the 891 and go to table. Cool. So I get that this is a 171.07 degrees, but honestly, I could probably just say 171 because there's no way you're graphing more accurately than that by hand, right? If it's a calculator, different story. But if you're graphing by hand, let's be reasonable. You know, it's hard enough to graph closer than, it's hard enough to get 170, right? So 627, and then I go back to my table eventually. And I get about $1.20, right? So again, I wouldn't stress it too much because if you're actually graphing this by hand, you're not going to be able to be that much more accurate. 235. And I get about 45 degrees. And again, that's, you know, approximate. So we'll say approximate degrees. And then back to my table, and I need the 122. And arguably, you don't need the 122 because you should be able to figure out by default that it's whatever's left, right? But we're just going to go ahead and say that's close enough, right? So if I were going to sketch this graph, what I'd have to do, and we'll see if we can drag this guy down here again for a sec. I think that's a better spot for it. So again, you start with a line. Usually, it's usually sort of horizontal in the direction of the positive x-axis. I hate this thing so much. There we go. Okay, so we're going to turn it, and we want to line it up so that this line is right at the center of the circle, so that this dot's at the center of the circle and this along the line, right? And then I'm going to make this one a little smaller because I need to be able to see the edge. So the other thing you can do, honestly, if you don't want to move the protractor a ton of times, is you can just add, right? You can say, okay, I want to go to 171, right? Well, this is 90, this is $1.80, so this is 171, right? And then if it hadn't been this far, you could have just actually added and said, okay, what would be the next thing on the protractor? Now here, because it is this far, right? We want, I think it's here if I wanted to rotate. There we go. So I'm just going to cheat and line up with that line. I know that line's my first one. For after the 171, I want a 120. Well, this is 90, 100, 110, 120. So that's my 120, right? And then again, I'm going to cheat and rotate. And from that line where the 120 is, I want a 45 and a 23. Well, there's 1, 2, 3, 4. So that's about my 45 and my 23. And it's not perfect, but you get the gist. Again, this is definitely not the best circle graph you've ever seen, but it's also not the worst thing that's ever happened. So, so we'll do something akin to like about there. Cool. And then if I were color coding this, right, I'd say, hey, liberal arts, you get to be this giant section here. And we'll make natural sciences this big section here. And we'll make undecided this section. And we'll make other this section. And that's what circle graphs look like. So that's kind of the gist of how a circle graph works. So yeah, personally, my very favorite circle graph looks something like this. It's this, right? And let's say this. And the color coding is something like Pac-Man, not Pac-Man. So there you go, favorite circle graph. And that's it for this video.